in 4.1. I'm looking for a problem. Solve it by graphing. Okay, for example, problem 9 on page 302. 2x plus y equals 5 and x equals negative 3y. So first I will definitely substitute. I will replace x in the first equation by negative 3y. So 2 multiplied by negative 3y plus y equals 5. This is negative 6y plus y is negative 5y equals 5. So I already know the solution for y, which is negative 1. And I do have to go back and get x. So negative 3 multiplied by negative 1 gives us x to be negative 3 times negative 1.
Positive 3.
Very good. So then we expect the solution to be
Negative, at 3, negative 1.
perfect. So now I'm asked to graph. This was my work on scratch paper, so I don't waste my time. Okay, so I will start by graphing 2x plus y equals 5, like we just did 5 minutes ago. When x is 0, how much is y?
5.
So then 0, 5. So now when y is 0, how much is x? 5 divided by 2, let's say 2.5, instead of a fraction. So this is 2.5 comma 0. So I will graph. This is a major part of this course, being able to graph linear functions or linear equations. 0 comma 5, 1, 2, 3, 4, 5. 2.50, 1, 2, 2.50. So this is one equation, which is 2x plus y equals 5. Now I want to graph negative 3y, x equals negative 3y. When x is 0, y is 0, obviously the function goes through the origin. But I already have this point. 1, 2, 3, negative 1. 1, 2, 3, negative 1. So here it is. So this is x equals negative 3y. And I'll say, look, my graph is so good. I can read from it. My graph is not good at all. But I knew the solution because I did my homework before I started graphing. And I found the solution before messing with the graph. My graph is awful. It's nowhere near a perfect graph. Nowhere near I could have read 3 comma negative 1. But I did my work prior to graphing, because it's more difficult. Now, if you have graph paper and so on and so forth, maybe easier and so on and so forth. But here what I have is, and a big marker, it's not gonna, my graphs can now be perfect. Okay? Is that clear? Do we need to go back to factoring?
Polynomials.
Yes.
I've been practicing since yesterday, I think. I'm good.
Do I have to review how to multiply and distribute? And
I got a question.
Yes.
Can you solve a couple of just binomials?
yes, which
It doesn't matter.
when you
just in
say
general.
solve, I'm thinking of an equation. If you say factor binomials, then I'm thinking of expressions.
I guess factor binomials.
Okay, very good. So let's do that.
I just have difficulty with just binomials.
Very good. Okay, let's take a look at a few examples. Let's say 9 plus x squared, that's 1.
Okay.
Number 2, 125x cubed minus 64y cubed. So that's the second one. 3, 9x squared minus 25. Okay, so let's start with the first one. Have to identify it's a binomial. It's in descending order. No, it's not. I will put in descending order. Then I'm going to ask myself, negative leading coefficient, no. Greatest common factor, no. Special product. Is this a special product?
Yes, it is.
Which one? Sum of squares. What do I write?
Not
Very good. Not factorable. Good. Good. The next one. Binomial, descending order. I would say yes. X and Y in that order. That's not bad. Greatest common factor. No. Negative leading coefficient. No. Special product. I hope for a special product. So what will? Say it again.
difference of cubes.
Awesome. Once you say that, once you identify it, you will have to present a binomial times a. Awesome. What will be the sign in the binomial?
Plus and negative.
So remember, the binomial follows what you are factoring. If what you are factoring has minus, you cannot put plus in the binomial.
Right, it's the opposite sign, right?
It has to be the same sign in the binomial. The binomial follows what you are factoring.
Oh, I was talking about the other one.
Yes,
Sign
the
is
other one has to be opposite.
Okay.
So remember, there are two sequences of signs: minus, minus, and plus,
Right.
or plus, plus, and minus. Good. Awesome. I need to identify what I cubed to get this.
5
Yes?
x
Very good. I need to identify what I cubed to get this.
4
4. That's it. Now, in the trinomial, I should not have difficulties because I square this and put it here, I square this and put it here, and I multiply them and put it in the middle. First one.
25 x plus squared
Good.
plus 20x squared
Awesome. Plus.
14 and 16 y squared and
Very good. Okay, the next one. 9x squared minus 25.
I do have one question.
Sure.
now.
Yes.
So I noticed that if you technically multiply 5x minus 4y, you would get negative, right? When you multiply those.
That's
but,
why-
But you don't change the sign.
That's
in the
why
trinomial,
we
right?
establish the sign first so we don't mess up the problem.
Right, so regardless of what you get there, it doesn't change. the
Once
sign.
you establish the sign from the beginning, that's it.
Okay, alright.
You should, at least for a couple of problems that you practice with, you should go and multiply and see that it's correct.
Okay.
What would you do? Distribute 5x to these 3, distribute negative 4y to these 3, and you see the correct terms go away and you have the left-hand side.
Okay.
Okay, the next one. It's a binomial, it's in descending order. No greatest common factor, no negative leading coefficient. Special product,
The difference in perfect cubes.
squares.
Different in perfect squares.
Yes, very good. If you say that, then you will prepare two binomials. What two binomials would you prepare?
minus and minus. Let's go for minus and plus.
Yes, it's a difference of squares.
So wait, the difference of squares is minus and plus, but the other questions that I do and it's minus minus. Like both signs are minus.
That's a trinomial.
Got it. Okay.
So would it be 3x minus 5 and 3x plus 5?
That's it. Check it out. It will take 10 seconds to
Right.
multiply. If you have any doubts. Good. Next question.
Can we do one with a power of 4?
Yes. So let's look at one with power. Do you want to factor or solve?
Factor.
Okay. So
So what's the difference between solve and factor? When
you are given an expression, you are only asked to change it from a sum of terms or difference of terms into a product of factors. That's it. You're done.
Okay.
When you're asked to solve, you are given a left-hand side. You are given the equal symbol. You are given the right-hand side. You are asked to solve for x. It must be an equation. An equation has a left-hand side, the equal symbol, and a right-hand side. This one is an expression. It's not set equal to anything. There is no other side. I said equals this because I changed it into a product. So there are two different things. When we are asked to solve, at the very end you have to write x equals. If you don't write x equals, you're not solving. When you're asked to factor, you have to have an expression that you're changing into from sum of terms or difference of terms into a product of factors. 1, 2, 3, 4 factors. I don't know how many. Okay, so if we want to factor, for example, x to the 4th minus 81. So this is a polynomial degree 4. If it were an equation, I would have had to write how many solutions? 4. But it's not an equation. We are only asked to factor. Good. So it's a binomial. It's in descending order. No greatest common factor, no negative leading coefficient. Special product. I always hope for a special product because those are easier than anything else. There are two options for the difference. If you remember, if you have that, you should carry on with that to your next, to the next class. The strategy of factoring that I gave you.
Does two so represent 2 by
Yes, it's a difference of squares. Very good. And we need 2 binomials. Good. Awesome.
so is it s squared
Yes?
minus
Yes?
9
Yes.
s squared plus 9
Very good. Which of these two I cannot touch because it's not factorable?
x squared plus 9?
Correct. But x squared minus 9 is factorable. So I will copy x squared plus 9. The order doesn't matter. And now I'm looking at x squared minus 9. And what will I say?
Is it x plus 3?
Good.
Plus 3. So x squared. P x plus 3.
I'm using the same formula that you used from here
Yeah.
for this.
Yeah.
If you say x plus 3 squared, then we are in big trouble. Because x plus 3 squared from chapter 3, we know it has 3 terms. The first term squared plus 2 times the first times the second plus the second term squared. So this cannot be true. So then,
X plus 3.
yes,
X plus 3.
but that's the same with x plus 3 squared. I cannot do that.
So what happens when you do this?
I'm using the same formula used from here for this. Very good.
Oh, got it.
Is that clear?
Mm-hmm.
Good.
Can we move around
Yes.
trinomials?
Yes. Yes.
The third one, like when there's no other special products and the number is other than 1.
Yes. Very good. So let's take a look at an example. Those problems are at the end of chapter 6. And we want to factor or solve equations. If you want to use it to factor. Okay, very good. So I'm looking on page 412. Page 412. And you said it has to be a trinomial. Let me see. Let's find a trinomial. a trinomial, a trinomial, a trinomial. Yes, let's say, yeah, but that has, okay. Oh, yes, 73. And this is on page 412. And we have 3x squared plus 2x minus 5. So this is a trinomial. It's in descending order. Greatest common factor? No, no greatest common factor. Negative leading coefficient? No. Special product? No, because this is -5 and it's not a perfect square, and 3 is not a perfect square. 1 is a leading coefficient? No. So I'm down to the very last possibility. If I say no to the last one, it's not factorable. Good. So at this point, I need to find two numbers whose product is
Right? No, 15.
sine.
Okay.
You have to take this and you have to take this. You cannot separate the number from the sign in front.
Negative 15.
I agree completely. And now I want the sum.
Positive 2.
Correct. If you put here 15, I'm not saying you will make, but if you put 15, you will never get it. It's very important. So now I always start with the product and I say this to myself. Okay, the product is negative. Obviously, one has to be positive and one has to be negative. Always start by looking at the product first. So I have a positive and a negative. So when I say a minus b, I get 2, right? And the product has to be negative 15. 5 and negative 3. Indeed. So now I will have to change the outlook of the expression I was given, not the value. I'm not changing the value. But I will be using what I just determined to make it easier on myself, because 3 terms like this are difficult. 4 terms will not be difficult. Can anyone dictate what to write?
This is the errors that I did in the exam. I did not multiply the last term. I said the last
That's
term.
why for the final exam, redo the remember the shortcut that I gave you? That should be moving forward. That should be something you should look at all the time.
So I have a question. So
Yes.
I usually remember it that, and this might be wrong, where if there is a one leading coefficient, you're supposed to break the middle term down. Is that not correct?
That's what I'm doing right now. I'm waiting for you to break this down for me.
But you multiply the last term by the leading coefficient.
Yes.
I don't recall ever doing that, but I guess
We did that all the
should have been
time.
doing that. Okay, sure. But I know sometimes like we take the middle term and like we break it down into its own
That's
thing.
exactly the step I'm doing right now. I'm waiting for you to continue to dictate, and I will write it down. Yes. Can anyone dictate? 3x squared.
No, plus
Plus
5x minus 3x minus 5.
This happens only because we multiply -5 by 3. Otherwise, I can't do it. I have to multiply 3 by -5, and the sum is 2 to find those numbers. You will not be able to find these numbers if you don't multiply 3 by -5.
Oh, I see. I figured out what I did wrong. So I assumed that the 5 and the -3 would be enough to solve the problem. So I did as
No,
the answer 3x
you
plus
cannot do
5,
that.
3x minus
You cannot.
5.
It's not going to work. Multiply.
That's okay.
So give me what you got. Give me what you got.
I did 3x plus 5, 3x minus 5.
Here's the answer. 9x squared minus 25. Do we have that here?
Right. Okay. All right. I see. All right.
So now it's just factoring by.
Now factoring by grouping. From the first two, what will you factor? Now you remember doing this, Chris?
Yeah. This,
Okay, good. So from the first two, what do I factor out? What is left in parentheses? What should I have coming out from the other two? Otherwise, I can't continue.
3x plus
Yes, I write it first. Please, it's a very good practice to write it first and then look. Yes.
minus 50. Oh,
So what is the common factor now?
3x plus 4.
And what do you have in parentheses? Good. Next question.
do you mind if we go over this session?
Go ahead.
This one right here?
Sure, of
It's
course.
linear.
Yes, of course. Yep. So here's a question from a previous test. 4 braces, 3 bracket, 5 in parentheses, negative y plus 3 minus 9 bracket, negative 3, close the braces now, minus 2 and parentheses y minus 8. Very good. So let's do this. Remember the starting point. We have 3 different grouping symbols here. We have parentheses, we have brackets, and we have braces. Where is the starting point?
Always parentheses.
Always parentheses, awesome. So I'm here, I want to eliminate these. That's my first step. I copy everything else without changing anything. So I copy the 4. Obviously there is no operation symbol, it must be product. I copy the 3, I copy the bracket, and now I'm here. 5 times negative y.
Negative 5,
5 times 3,
15.
positive 15 minus 9. Copy, copy, copy. Minus 2 times y.
Negative 2, 1 plus.
Very good, awesome, awesome. So now, before I try to eliminate this, I want to combine like terms in here. That's my next step. I don't do anything else. I copy everything else step by step. So I have 4. I copy the brace and 3. I copy the bracket, negative 5y. I can't do anything. And 15 minus 9 is positive 6. Copy, 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 copy. My next step now, I want to eliminate this. Those 2 should go away in this step. I copy the 4, I copy the brace. But now since there is no operation symbol, obviously it's multiplication. 3 times negative 5y,
Negative 15.
3 times positive 6,
18.
minus 3. I'm here. I copy, 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 copy.
See, the mistake I did was when I got to this point, I brought like terms together, negative 5y plus 6 minus 2y plus 16.
You cannot do that. These are outside. You have to eliminate everything before you get here.
Okay.
Is that clear now?
Mm-hmm.
Okay. So now my target is to eliminate this. Not yet, because I can perform some operations here first. Copy, 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 15, copy, copy, copy. Now I want to eliminate this. You know, to eliminate this, there is no operation symbol, it must be a product. 4 times negative 15 is negative 60. And plus 60. And minus 2y and plus 16. Now they are all together and I have to combine my terms and put it in descending order, right? So this with this will be negative 62y and this with this will be plus 76. So you really have to take it slowly. You have to eliminate what you have, the order, braces first, forgive me, parentheses first, brackets and then braces, and then when there are no more grouping symbols, then you can continue. You cannot jump from here, right? You have to perform the operations inside. You can no longer do that, so you have to distribute. Any questions? What about if we are given some ordered pairs? Let's say we are given 1, 4, -3, 2, 1, 5, and we are asked, does this represent a function? I have no idea. Here's one way. 1 corresponds to, perfect. -3 corresponds to,
2.
and 1 corresponds to 5. Is this a function?
No,
No. Not a function. It's a relation.
because they have 2 ones.
Exactly, because to each x, it must correspond only one y. I can have 2 different x values going to the same y. That is allowed. But each x has to correspond to only one y value. Okay, what would be the domain? It's not a relation, it's not a function, it's a relation, but what would be its domain?
Be 1 and -3.
Very good. With braces. What would be the range?
That would be 4, 2, and 5.
Very good.
So if the last product was 2 and 5, then it would be a function.
If the last one were 2 and 5, yes, it would have been a function.
And if the last one was 1 and 4, it also would have been a function, right?
Oh yeah, because you cannot, there is no need to list the same ordered pair twice.
Okay, so if there's
Yes.
if there's no need to list the same ordered pair twice, then I
And
can remember
if it is listed, it's just to trick you.
it's just to trick you.
Right. If it's the same value, I can write 1, 4 10 times if I want to. It doesn't mean that I have 2 points. I still have 1.
Right.
Can we do another one?
Yeah. So for example, let's say I have -5, 2, 4, 3, 10, 2, and -1, -2. Is this a function? I don't know. I create my bubbles on the side or scratch paper, and I put -5 corresponding to 2. I put 4 corresponding to 3. I put 10 corresponding to 2. And I put -1 corresponding to -2. Is this a function? Yes. To each x, only one y. It is allowed that 2 x values go to the same y value. That is okay.
Oh, so when it comes this way, then it's not a function.
It's not a function.
Oh.
Okay? So what is the domain? I will put it in order. -5, -1, 4, 10. What is the range? I will put -2, 2, 3.
Got it. Oh.
But this is a function.
Let me take a picture.
Yes. What if I'm asked to solve this equation? Let's say m equals c times t. Let's say I'm asked to solve for c. How would you solve this equation for c? Divide both sides by t, so what would you write? Very good.
I want to, right? I wanted to take a picture, but yeah.
I think it's better if you take the picture
Yeah.
of that. Let's do some exponents. Like, for example, 2/3 raised to -4. For example, -2x y squared everything to the third. Let's say over x to the fourth y squared. And let's simplify these two. How will I simplify them? So remember, no negative exponents in the final answer is one of the requirements. So what will I write for this? When I raise a fraction to a negative exponent, what do I do?
It changes.
Flips, and the exponent becomes
Positive.
awesome. So this is 3/2, everything to the fourth, and now you can write 81/16, and it's done. What about the next one? Here's what I would like to do. I would like to cross out an x from here with an x from here. Yes, allowed, no, not allowed.
Not allowed.
3 appalled. Allowed, not allowed, or appalled.
I think you can allow it. You can cancel x out and y out. No, y squared out.
You can't allow it, they're different powers.
You should be appalled for me even asking you that question. Why? Because x is inside parentheses with a power,
Right.
and this x is outside without a power. And completely gone. I mean, different
I'm sorry.
situation. Yes.
So when it's both in parentheses,
Depending on the power, it's a totally different situation. So by the order of operations, I have to take 1, 2, 3 factors to the third power and then see what else I can do. -2 to the third, please.
-8
Perfect. X to the third.
is x,
To the third. Y squared cubed.
y 5. You don't add it?
It's y to the 6.
Indeed. Remember, when we multiply exponential notations with the same base, we add the exponents. When we raise them to a power, we multiply the exponents. When we divide the same base with different exponents, we subtract. Okay? So this must be copied. So power 1 times power 3 is 3. Power 2 times power 3 is 6. And then x to the fourth, y squared. -8, no one can change. Copy the base. What happens to the exponents for x?
You subtract that.
From 3, always from the one from the top, I subtract the exponent of the bottom. What do I get?
A negative exponent of 1.
Good. I copy the base. What happens to the exponent for y?
I'm sorry, well, how did you get a -1?
3 minus 4 is -1. And y, which power?
To the 4th.
Good. Which of these 3 quantities, factors, in other words, will go to the denominator? Only x. Negative stays in front, 8 stays at the top, y to the fourth stays at the top, and x goes to the denominator. Great. If I ask you this question, is x minus 1 times x plus 1, don't do anything, just say yes or no. Is this a special product? Thank you. Which page? Is this a special product?
X squared -1.
Exactly. So is it a special product?
No.
It's listed under the special products. You just told me it was x squared minus 1. You didn't have to FOIL it. So if you don't have to FOIL it, it's a special product. You immediately said x squared minus 1. So it's a special product. It's a difference of squares. Right?
So wait, I thought the only special product is when it's s squared plus 1.
All these are special products. They are in chapter 5. We treated them as special products from the very beginning. So this difference of squares is a special product, the sum of squares is a special product, the difference of cubes is a special product, the sum of cubes is a special product, the difference binomial difference squared is a special product, and its binomial sum squared is a special product. All these are special products.
So out of curiosity, what you're saying is the last example you gave us is one of these, but fully factored. But it's still a special product, though, is what you're saying?
A special product is applicable to them.
Oh.
I can treat those expressions with a special product.
Right, so they don't need to appear like they do on this form verbatim.
No.
Right, okay.
That's why I said, do not remember as a long time ago, I said, do not remember it as A and B.
Right,
Remember it's the first term squared minus the second term squared, because it can be anything.
correct, okay.
Okay, so this is a special product, it's the difference of squares. It even has a name, right? What about this one? Let's say I have x squared minus 1, let's say plus 1 or plus 7, it doesn't matter, and x minus 3. Is this a special product? No. X squared plus 7 times x minus 3, I have to FOIL it. It cannot be a special product. I cannot do it in my head. This one I can, because I know it's a difference of squares. It must be x squared minus 1. It's done. But this one I have to distribute. What about this? Is this a special product? Yes. Which one? Although the problem may not ask you which one, but it is a special product because this is a trinomial.
It's the first one.
Yeah, x minus 1, everything squared. Because I know from chapter 5 from polynomials that this expands first term squared minus 2 times the first times the second plus the second term squared. So this is a special product. What about this? Last question. X minus 1, x squared plus x plus 1. Is this a special product?
No,
I think it is.
it's S cubed.
Yes? Indeed.
Yeah,
This is a special product. It's a difference of
because you
cubes.
said, oh, when you see
Oh,
difference
when
of cubes, it has to be a binomial and a trinomial.
Got it.
Yes.
That's the binomial trinomial.
Now, if I change this and I put a 2 in here, it's not a special product.
Right.
And you have to FOIL. You will not be able to write the answer right away.
Yeah.
I think you learned a lot, but you still